Hello everyone. In today's lecture, we shall discuss about the few numerical problems based on electric flux and Gauss theorem. In yesterday's lecture, we have discussed about some descriptive problems and now some conceptual problems. Now today we shall discuss about some numerical problem. And for the solution of question number 1, I am starting from here. Answer 1. The question is the net outward flux through a surface of a box is 8 into 10 raised to the power 3 Newton into meter square upon Coulomb. What is the net charge inside the box? The flux is given to us, the value of phi E is given to us, that is nothing but the integral E dot dA, and it is given to us 8 into 10 raised to the power 3 Newton into meter square upon Coulomb. And we know that from Gauss theorem, integral E dot dA means phi E is equal to summation Q upon epsilon. And then, what is the net charge inside the box? This is the first part. So, if we want to calculate the value of charge, Q is equal to epsilon naught phi E. The value of epsilon naught 8.85 into 10 raised to the power minus 12 into the value of flux 8 into 10 raised to the power 3 Newton into meter square upon Coulomb. So the answer will be in Coulomb. And the answer will be now the question number 2, a point charge of 2 microcoulomb is at the center of cubic Gaussian surface 9 cm on edge. What is the net flux through the surface? The answer of question number 2 is the magnitude of charge is given to us. Q is equal to 2 microcoulomb, means 2 into 10 raised to the power minus 6 Coulomb, and the each side or each edge of the cubic Gaussian surface is 9 cm. What is the net flux? And we know that according to Gauss theorem, phi E is equal to Q upon epsilon naught. The value of Q is 2 into 10 raised to the power minus 6 upon the value of epsilon naught is 8.85 into 10 raised to the power minus 12, and the answer will be 2.26 into 10 raised to the power 5 Newton into meter square upon Coulomb. So the answer, a point charge of 2 microcoulomb is at the center of a cubic Gaussian surface 9 cm on edge. The each side of the cubic Gaussian surface or cube is 9 cm. What is the net flux? And flux is phi E is equal to Q upon epsilon naught. The value of Q is 2 into 10 to the power minus 6 upon epsilon naught 8.85 into 10 raised to the power minus 12, and the answer is 2.26 into 10 raised to the power 5 Newton into meter square upon Coulomb. This is the answer of the question number 2. Now answer of question number 3 is what? A conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 raised to the power 3 Newton per Coulomb, and points are radially inward. What is the net charge on the sphere? We know that the electric field intensity at a distance 20 centimeter is 1.5 into 10 raised to the power 3 Newton per Coulomb, and the distance is small r is 20 centimeter. 20 centimeter means 0.2 meter, and radius of the sphere is 10 centimeter means 0.1. Means the point P is situated outside the sphere, and in this case we know that the electric field intensity due to a conducting sphere is kq upon r square, because a conducting sphere behaves like a charged spherical shell, because no charge exists inside the conducting sphere. Whole charge is accumulated on the surface of the sphere. So a conducting sphere can be assumed as a electric uniformly charged shell or spherical shell, and the value of Q is equal to ER square upon K. The value of E is 1.5 into 10 raised to the power 3. The value of R is square 0.2 into 0.2 upon K, 9 into 10 raised to the power 9. On solving this, the answer of charge will be is equal to 6.67 into 10 raised to the power 9 minus 9. This is the answer of the question number 3. Since the electric field intensity is radially inward, so the nature of charge will be negative. So the answer of the question number 3 will be minus 6.67 into 10 raised to the power minus 9 Coulomb will be the answer of the question. Now we shall discuss about the question number 4. Answer of question number 1 is 0.07 into 10 to the power minus 6 Coulomb. Question number 4. An infinite line charge produces a field 9 into 10 raised to the power 4 Newton per Coulomb at a distance of 2 centimeter. Calculate the linear charge density. In the case, the value of electric field intensity is given to us 9 into 10 raised to the power 4 Newton per Coulomb, and the distance r is given to us 2 centimeter. 2 centimeter means 2 into 10 raised to the power minus 2 meter. And we know that the value of electric field intensity will be 2k lambda upon r. And the value of lambda is ER upon 2k. The value of E is, we know that 9 into 10 raised to the power 4. The value of R is 2 into 10 raised to the power minus 2 upon 2 into 9 into 10 raised to the power 9 into 10 raised to the power 9. Value of E is 9 into 10 raised to the power 4. The value of R is 2 into 10 raised to the power minus 2, 2 centimeter upon 2 K. The value of 9 into 10 raised to the power 9. 2 and 2 cancel out, 9 and 9 cancel out, and the answer will be 10 raised to the power minus 7 Coulomb per meter, or 0.1 into 10 raised to the power minus 6 Coulomb per meter. This is the answer of the question number 4. Now we shall discuss about the last question for today's lecture, and that is nothing but the question number 5. The answer of the question number 5 is, this is question number 5. Two thin metal plates are parallel and close to each other. A thin on their inner faces, the plates have surface charge densities of opposite sign, means one plate is charged with positive sign and other one is with negative sign, and the magnitude is 17 into 10 raised power minus 22 coulomb per meter square. What is the electric field on outer region of first plate and outer region of second plate and between the plates? Now first we consider two plates, and also yesterday we have discussed about such kind of conditions. This is positively charged plate, this is plate P, this is plate Q, this is positively charged plate, and this is negatively charged plate, and the value of sigma surface charge density will be 17 into 10 raised power minus 22 coulomb per meter square. Here is plus sigma and here is minus sigma. And then we have to calculate the electric field on outer region of first plate A, outer region of second plate B, and between the plates means 8.6. If this plate is P, then direction of electric field intensity will be along away from the plate, means EP, and the direction of electric field intensity due to Q plate will be towards the plate, and the net electric field intensity at point A will be EA is equal to EP minus EQ is equal to sigma upon sigma upon 2 epsilon naught electric field intensity due to first plate plus sigma upon 2 epsilon naught, and this is with negative sign because both electric field intensities are opposite to one another. So the electric field intensity at outside the first plate is 0. The direction of electric field intensity due to this plate is away from the plate, and the direction of electric field intensity due to negatively charged plate is towards the plate. EP and EQ are opposite to one another, so there will be a difference of the net electric field will be equal to 0. This is sigma upon 2 epsilon naught plus minus sigma upon 2 epsilon naught, and total value will be 0. Similarly, the direction of electric field intensity at point B outside the second plate is EP away from the plate, and this is towards the plate, and the value of EB is equal to EP minus EQ, means sigma upon 2 epsilon naught plus minus sigma upon 2 epsilon naught, and net electric field intensity will be equal to 0. At point C, the direction of electric field intensity will be along this direction, EP, and direction of electric field intensity also towards the negative plate, EQ, and the value of EC is equal to EP plus EQ because both are along the same direction, means sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught means sigma upon epsilon naught, and value of sigma is 17 into 10 raised to the power minus 22 upon 8.85 into 10 raised to the power minus 12, and when 17 is divided by 8.85, the answer will be 19.2 into 10 raised to the power minus 10 Newton per coulomb. This is the magnitude of electric field intensity between the plate, and because this electric field intensity is independent of distance r, so it produces a uniform electric field between the plates. These are the few questions which I have selected for today's lecture. Thank you.